All right, so a projectile fired over level ground has initial total velocity of 47.4 meters per second, and it's in the air for 5.7 seconds. What's the x component of the projectile's initial velocity? Yeah, it's basically the same thing. So, yeah. So but let's go ahead. It doesn't hurt to go through it a second time, right? So, draw the picture. Somewhat level ground. we'll make it be on level ground. So this is our projectile. It's gonna get pushed in this direction at 47.4 meters per second. It travels this path. Lands right here. I don't know what right here is, but there's a couple of things they tell me that I do know. I know that the total time, just like before, if we know that the total time is 5.7, but when it's at its maximum height, it'd be 1/2 of that. So what's that? Let's find out on the calculator. 2.5. That's going to be a weird one. So 5.7 divided by 2. 2.85. So that's going to be. It'll reach its maximum height in 2.5 seconds. Now the question is, they want us to figure out what's the velocity in the x direction. So this is v sub x. What the world? So weird. V sub x 0. That's what we need to find. They gave us v initial. And in order to find that, just like we did for problem number 13, we're probably going to need to know our v sub y. Okay. Well, v sub y is pretty easy to find. We just know that the final velocity is equal to the initial velocity, we're talking about the y direction, plus the acceleration times time. Well, we know what time is. Right here, what's the final velocity in the y direction at the maximum height? 0 meters per second, right? Because it's going up, and it stops right there, and then it comes down. So in that instant, it's 0 meters. So this would be 0, okay? We don't know what this is, because that's what we're solving for. The acceleration due to gravity is negative 9.8, so we've got minus 9.8 meters per second squared. And all of that is going to be multiplied by 2.85, running out of space, seconds. So let's do that on our handy dandy calculator, shall we? So I'm going to say 2.85 times 9.8, but it's a negative number, so it'd be negative 27.93. Negative 27 point, was that 93 or 83? 93, okay. Meters per second. This is the same, and this is the same. We're going to add that to both sides. And I get 27.93 meters per second is equal to my velocity in the y direction, the initial velocity. So this is 27.93. All right, well, remember that relationship that these had was that v naught squared is equal to v sub x squared plus v sub y squared, right? That's just the old-fashioned Pythagorean theorem, right? Learned that in the 6th grade. A squared plus b squared equals c squared. But now we're doing all this fancy math that looks really hard, but you guys got this. So I'm going to plug this in. So I say 47.4 squared is equal to this thing squared plus 27.93 squared. All right, let's plug those in. I'm taking the old school approach. Clear this out. I've got 47.4 squared. Oh man, that's a big number. 22. I'm gonna move this over here. 2246.76 is equal to x squared. And now I'm going to do the 27.93 squared, which is 780. Oh, shoot. Why did I write it like that? .08. I'm going to subtract the 780.08 from both sides. So we say 2246.76 minus 780.08. Does that seem right? 1466. Let me double check all my math. Yeah, so let me write that down. 1466.68. 1466.868. Now what do I do? Yeah, gonna have to take the square root of both sides. Oh, this is a lot of work. I see. If you guys complain about work, I wouldn't mind, because I get it. What do you think? About 39, roughly? No, 38. Huh? Oh, is that one of the answers? Yeah, is it? Okay. So then we did all that work and we found out that this is approximately 38. Now the textbook does it a little different. They do that thing where they do use the range equation and all that stuff. I don't. It works because it's symmetrical. It is the final y position, but it assumes that the initial y position is 0. There's another one where you say y minus y naught, blah, 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 blah. You need to separate it. The reason that so remember on problem number 13, was it problem 13 where I had you write a bunch of stuff? I said, I don't like this, let's do it the other way. The reason that works is because you're doing the same stuff twice, right? So on problem number 13, we're going up and then we're coming down. Well, what's our initial position here for the y direction? 0. And then what's our final y position here? 0. And what's our time? It's double the time. So we're doubling the first half. We're basically doing this math, multiplying it by 2, and then dividing it by 2. It's just the way the equations work out. The problem is at some point, we're going to have a problem where you're on a cliff and you shoot that thing up in the air, and then it's going to land way down here. And the way that they did that problem only works if it's on level ground because there's symmetry. When you have something that looks like this, you'll get a really bad answer because your y naught is going to be in a completely different spot. Or not your y naught, your final y. And so you have to separate them. Okay, because it's not symmetrical. It won't be the same. All right. Are there any other questions? Oh, it's almost time to go. So now here's what my advice